All right, let's dive into a bit of a scientific detective story. The mystery? How a tiny grain of sand from Africa is causing multi-million euro problems for Europe's green energy plans. It's a wild tale of how our changing climate is creating some really surprising and very expensive new challenges. So, to get what's going on, we got to look at the big picture. To meet its climate goals and, secure its energy future, Europe is making this massive continent-wide bet on solar power. It's pretty much one of the cornerstones of the whole green transition. And it's really easy to see why this is such a good bet. I mean, just look at this map. It shows the huge solar potential across the continent. With thousands of hours of sunshine every year, the conditions are just about perfect for a solar revolution. And countries are building solar farms at a breakneck pace. Just to give you a sense of the scale here, take a look at Hungary. Between 2020 and 2023, its solar capacity just exploded by 235%. This isn't some gradual shift, it is a full-on solar gold rush happening right now all across Europe. But here's the thing, you can't just slap up a bunch of panels and hope for the best. To keep our lights on, the people who run the power grid have to perfectly match the supply of electricity with our demand, like second by second. And for that to happen, you absolutely must know how much power your solar farms are going to generate tomorrow. Okay, so there's a huge problem. Lately, those critical, super high-tech forecasts, they've been going spectacularly wrong. And we're not talking about a small problem. We're talking millions of euros in penalties, not to mention the risk of the whole grid becoming unstable. So what in the world is going on? What invisible force is throwing these super complex models so far off course? This chart right here, it lays out the problem perfectly. The gray bars show the actual power they got each day, and that crazy orange line, that's the error in the forecast. Those huge spikes mean on some days they were wildly overpredicting power, and on others, underpredicting. It is a grid operator's absolute nightmare. And look, this isn't just some technical glitch. The financial hit is massive. In Hungary alone, the penalties for these forecasting errors cost a staggering 372 million euros in just 1 year, 2021. Now just imagine that scaled up across all of Europe. You see, this whole process, it's called photovoltaic forecasting, and it is so crucial. When it works, the grid is stable, it's clean, but when it fails, they have to fire up these expensive, polluting gas plants at the very last minute just to keep the lights from going out. So the stakes are incredibly high for both our wallets and, well, the planet. So, who's our culprit? Well, all the evidence points to a suspect that's thousands of kilometers away from the crime scene. Yep, that's right. The key to this whole multi-million euro energy mystery lies right in the middle of the Sahara Desert. Here we go. This is the first major clue. This chart tracks Saharan dust events reaching Central Europe over the last 40 years. Now, notice what happens right around 2010. The frequency, the intensity of these dust storms, it just climbs dramatically. More dust is traveling farther than it ever has before. And this map shows you the atmospheric highways that these dust plumes travel on. They get carried from North Africa right over the Mediterranean and slam into the heart of Europe, which is precisely where this whole solar power boom is happening. But it's not as simple as dust just casting a shadow. No, the real effect is way more complex. Because this isn't just about some dusty haze dimming the sun. What's happening is the dust is actually changing the weather itself. It's basically a cloud-making machine. So here's how it works. These tiny dust particles, they get blown way up high into the atmosphere, where they act like little seeds. Water vapor, which might have just stayed invisible otherwise, starts latching onto these dust particles. And this process creates these vast, dense, high-altitude clouds that the weather models, they just don't see them coming. And this right here, this is the smoking gun. On the left, you've got a model forecasting a plume of Saharan dust over Europe. On the right, the real satellite images from the same time showing a massive blanket of clouds in the exact same spot. The dust isn't just under the clouds, it's literally creating them. And this is what that looks like on the ground. This chart shows a specific dust event in March 2022. The forecast expected a pretty good amount of solar power, but because of those unexpected dust-seeded clouds, the actual production, that's the blue line, was way, way lower. That huge red area shows the deficit, all the power that was promised but just never showed up. But just when you think the mystery is solved,
there's a plot twist. Sometimes the dust does the complete opposite. It's like the dust has this dual personality. On what scientists are calling deficit days, it acts like that cloud factory, causing power generation to be much lower than they predicted. But then you have these surplus days, where, for reasons they're still figuring out, the dust seems to help break up existing clouds. This leads to clearer skies and much more power than forecasted. It's a total contradiction.
And this chart shows a surplus day. So here, the models predicted cloudy skies, low solar output. But the dust plume that arrived seems to have actually helped break up the cloud cover. The result? That big red area shows a massive surplus of power that the operators just were not expecting. And it's this complete unpredictability that makes the problem so hard to solve. And this really gets to the heart of the issue. As the researchers themselves put it, our atmosphere is already this incredibly complex thing that's hard to predict. Well, climate change is basically turning the dial up on that complexity, making these weird, surprising interactions, like dust both making and breaking clouds, way more common. So, now that we know the culprit and its bizarre, contradictory methods, what's the verdict? And how do we fix our forecasts for the future? Well, the current weather models, they have these massive blind spots. They're built on old data, not real-time dust storms. They treat all dust particles like tiny, perfect little spheres, when in reality they come in all sorts of shapes and sizes. And crucially, they don't yet understand the complex chemistry, how different minerals in the dust interact with the atmosphere to create these completely opposite effects. You know, this whole Saharan dust mystery is more than just a weather puzzle. It's a warning. We're trying to build a stable, predictable green energy system, but we're building it on a planet whose fundamental systems, its winds, its weather, its dust, are becoming less stable and less predictable. So the real question isn't just about how we forecast dust, but how we build a resilient green future for a world that simply refuses to sit still.